today we're going to do section 7.4. You'll want your calculator for this section, so you can just kind of put it to the side. The first thing that we're going to do is you're going to want to make sure that you look over this. This is Pascal's triangle. This is what we're going to use in order to solve these problems. So down here with the coefficients arranged in this way, each number in the triangle is the. And so if you look here, every row starts with the 1 and it ends with the 1. The way that you get the numbers in the middle is you take this 1 and that 1, and that's where the 2 came from. Same thing here. 1 plus 2 is 3, 2 plus 1 is 3, and that's how you work your way down the triangle. So here, this is the sum of the two numbers directly above. And then here, to find the coefficients, it wants us to find this last row. So what I'm going to do out here is I'm going to label this as x to the 0, x to the first, and I'm going to keep going down. That's the way that you know which row that you're going to use. This is x to the 4th, and this is x to the 5th. So if we're raising something to the third power, you're going to come in here where it says x to the 3rd, and you'll use that third row. So what it wants us to do is find the coefficients for x plus y to the 6th. So we want to go down here, and we want to fill out this triangle one more time. So you're going to start with the 1, and then remember you add these two together. So 1 plus 5 is 6. 5 plus 10 will be 15. 10 plus 10 will be 20. 10 plus 5, 15. 5 plus 1 will be 6. And then you end the row with a 1. So that's what's going to go here in this next blank. 1, 6, 15, 20, 15, 6, and 1. So that's how you find the numbers in the row of Pascal's triangle. We'll come back and work some problems with those in just a second. Next thing we're going to do is n factorial, and that's the exclamation point here. So the formula for it is you start with the n, then you multiply by n minus 1 times n minus 2, and basically what you're doing is you're just decreasing each term. And then 3 times 2 times 1. So you're just multiplying all the numbers together. If you're starting with 5 factorial, it will be 5 times 4 times 3 times 2 times 1. So that's how you do a factorial problem. And then here, anytime you have 0 factorial, then that's going to be equal to 1. All right, the next thing is called binomial coefficients. The way you say this is n choose r. You can also write it as n with an r in the bottom in parentheses. Notice it's not n divided by r, it's n in the top, r in the bottom. So n choose r. So either one of these, if you look at these problems, letter A and letter D would mean the same thing. I could write letter D, or I could write this one as 6 choose 2, and it means the exact same thing. Same thing on D. This would be 12 and a 10 with the parentheses. So both of those mean exactly the same thing. The formula for it is you take n factorial divided by r factorial, so the top number divided by the bottom number, and then you subtract those two, and then make that a factorial. So we're going to do this first one. In the top, I start with 6 factorial divided by 2 factorial, and then it says to subtract the 2, which is going to be 4 factorial. So that's how I set my problem up. Well, then I'm going to work the problem. I'm going to work it out. So this is going to be 6 times 5 times 4 times 3 times 2 times 1. Down here at the bottom, 2 will be 2 times 1. And then here, this is 4 times 3 times 2 times 1. And if I notice here, when I stopped at 4, everything after 4 is going to be repetitive with everything in this 4. So you could have stopped right here and just put 4 factorial over 4 factorial, and then known that everything behind that was going to cancel out. And I'll show you that in the next step. Alright, so here what I'm going to do is I'm going to cancel anything I can cancel. So the 4's cancel, the 3's cancel, the 2's cancel, and the 1's cancel. So all of that will cancel, because the same numbers in the top and the same numbers in the bottom. Then I see that 2 will go into 6 3 times, so I'm just going to reduce that. And so then you just multiply what you have left. In the top I have 3 times 5, which is 15. And in the bottom I just have 1 times all these 1's, which is going to be over 1, so my answer is 15. Right, so same thing on this problem. I have 8 factorial in the top. I have 0 factorial on the bottom, which we know from the previous page, that means it's 1. And then you subtract the 2, which is 8 factorial. So what I'm going to do here is I know that everything in the top is going to be 8 times 7 times 6 times 5, and if I keep going, that's going to be the same thing here. 8 times 0, everything is going to cancel. So do you see that this and this are going to cancel each other out? They're the exact same things. You'd have everything in the top, you'd have the same things in the bottom. So basically I have 1 over 0 factorial, but we know this is equal to 1. So I have 1 over 1, so my answer is just 1. So that one was pretty simple. Okay, same thing here. 10 factorial over 10 factorial, and then when you subtract the 2, you get 0 factorial. So this one's going to end up being just like letter B. So again, everything here, this will be 10 times 9 times 8 times 7. You keep going. They will cancel each other with everything right here because they're going to be the exact same numbers. So I end up with 1 over 0 factorial, which again is just going to be 1. Then for letter D, I have 12 factorial in the top, I have 10 factorial in the bottom, and then remember you subtract the 2. So 12 minus 10 is 2 factorial. So in the top I have 12 times 11 times 10, but I know that this and this one that's in the bottom, everything is going to cancel. They're going to be the same numbers, 10, 9, 8, 7, 6. So I'm going to just stop right here. So what I'm going to do is directly below that, I'm just going to shift this 10 over. Because I know that everything after that is going to be repetitive. So the 10s will cancel, the 9s, the 8s, the 7s, all the way down through the rest of that problem. And then I've got the 2, which is 2 times 1. So that'll make your problem a little bit easier if you don't have to write all those numbers out. Right, the 10s cancel. 2 will go into 12 6 times. Again, multiply what you have left in the top. 6 times 11 is 66. And then in the bottom again, 1 times all that is just 1. So your answer is 66. So that's how you do them by hand. So now what I'm going to do is I'm going to show you how to do these in the calculator. So if you go into your calculator, what you're going to want to do is, if you look here under math, and then you go over here to this last option, which is probability. I just did my back arrow. Option 4 is just your factorial button, and then option 3 is your N choose R button. So I'm going to use option 3 for these problems because they're all N choose R problems. What you have to do though is you have to put your N number in first. Then you're going to go into math and probability and tell it what you're fixing to do, and then you're going to put in the R function. Alright, so I'm going to start with example A. Remember example A was 6, choose 2. So I'm going to clear out of this. So I have 6, that was my top number. Then I go into math, over to probability, option 3. And so now it says NCR, which is what I'm doing, but I'd already put my N in first, so now I need to tell the calculator what R is. So R for this problem is 2. Then when I push enter, I got the answer of 15, which was the exact same answer that I got right here when I did it by hand. So now I'm going to go in and I'm going to do D also, just to show you one more. So that's 12, choose 10. So 12, go to math, over to probability, again go down to option 3. And then my bottom number, which is my R, is going to be 10. Then when I push enter, I get 66, which was the same thing that I got when I worked it by hand. So this just saves you a little bit of time if you want to do it on your calculator. Alright, now we kind of summarize the binomial theorem and Pascal's triangle. So it says here, there are, if you look back at Pascal's triangle, here, if x was to the 0 power, I had 1 term. If x was to the 1 power, I ended up with 2 terms. And so if you keep going, this was x squared row, ended up with 3 terms. So you always end up in the row of Pascal's triangle with 1 more term than what was listed over here. So there will be n plus 1 term. So if this were x to the 4th, you know that you're going to have 5 numbers in your line. If this were x to the 5th, 5 plus 1 is 6. So you're going to have 6 terms whenever you expand it out. So it's just a way for you to check. The first term, what you do is you always take x to this highest power. X is going to be to the n power. And your last term will be y to the n power, which will be this one to that power. And then it says in each succeeding term, so the way that you set up your problem is this is always going to, whatever the exponent is for x, which is your first piece in the problem, it will decrease by 1. And the exponent on y, which is your second piece, it will always start at 0, and it will always increase as you go across. So x decreases by 1 and y increases by 1 as you go across. Again, what we did earlier, the sum of the exponents on x and y is always going to be, if you take the two exponents, it's never going to be higher than what your original exponent is. So the sum of the exponents will always be n, so that's a way for you to check also. And then this last term says the coefficient, the way that you get the numbers in front, you just look at the row of Pascal's triangle. So that's how you determine what numbers need to go in front. Alright, so we're going to work a problem. So I'm going to flip back over to the front so I have my Pascal's triangle kind of right here beside me. So this says 3x plus 5 to the 4th. So I'm expanding this to the 4th power. So your other option is to write this down 4 times and you can pull it out, which is going to take you a little bit of time, and you're going to have to be careful not to make any careless mistakes with your signs and with your variables. So I'm going to use Pascal's triangle. This tells me x to the 4th. So what I'm going to do is I'm going to go to my x to the 4th line. So that's going to be the numbers that I'm going to use out in front, the coefficients. So that's the row that I'm going to use. So the way that you set it up is you always have 3 things. The first thing comes from the triangle. So the first number of the triangle was 1. Then you have 3x, which is the first piece of the problem. And from our last notes, it says it's going to start to this power, which in this case is 4. It's going to remember decrease as you go across. And then you're going to have the third thing, the 5, which is the second piece of the problem. It will always start at 0. So the 1 came from the triangle. The 3x came from right here. It is always raised to the highest power, which in this case is 4. And then the third thing is the last piece of the problem, which is the 5, and it always starts to the 0. Notice I'm multiplying all this together. It just said at any point I should be able to add these two exponents together, and it should not be bigger than 4. So 4 plus 0 is 4. Plus, go back to your triangle. The next number in the triangle is 4. Then I've got 3x. Remember, this decreases by 1, so this is going to be to the 3rd. And then you have a 5, and this is going to increase by 1, so it's going to be to the 1 power. So every time you have 3 things, a number from the triangle, 3x raised to a power, and 5 raised to a power. 3 plus 1 is 4, which is my exponent. Plus, go back to the triangle, the next number is 6. Then you have 3x. If I decrease by 1, it is now squared. And then I have 5. If I increase that by 1, it is squared. 2 plus 2 is 4. So it's just a built-in check to make sure my exponents are right. Next, 4, again, 3x. This time it is to the 1 power, and 5 is to the 3rd power. And then my last piece, I have a 1 from the triangle. I have 3x to the 0, and then I have 5 to the 4th. So usually this is the longest part, it's just writing it all out. So notice, every time I have 3 things. The first number came from the row of the triangle. The second thing, every time, was 3x. It started to the 4th, then it's to the 3rd, then it's squared, then there's 1 of them, then there's none of them. And then the last thing is a 5 every time. It starts at 0, then 1, then 2, then 3, then 4 of them. Alright, you may want to make yourself a note. Anything to the 0 power, or exponent, is 1. If you don't remember that. So, now what I'm going to do is I'm going to use my calculator to do this multiplication for me. So here, anything to the 0 power, so that piece goes to 1. So stick the rest of your numbers in your calculator. So what you have left is 3 raised to the 4th power. You see, exponent means 4. And then it's just times 1. So that's going to be 81. So your first number is 81. And then you go back and do the variables. X to the 4th. Do the same thing here. I've got 4 times 3 to the 3rd times 5. And it's to the 1 power. So I'm just letting my calculator do all that for me. that's 540. So 540 x to the third. I'm just going to keep going all the way across. 6 times 3 squared times 5 squared. So again, I'm just letting my calculator do all the multiplication. This rooftop button is my exponent button. So that gives me 1350, 1,350 x squared plus 4 times 3 times 5 to the third is 1,500 x to the 1 power. And then my last piece, anything to the 0 power is 1. Remember, all of that is raised to the 0 power. So that whole piece, all of 3x, goes to 1. So then what I have left for my last number is 5 to the 4th, which is 625. And that is your answer. Notice your variables, x to the 4th, x to the 3rd, x squared, 1x, no x. And then I use my calculator to get those numbers once I have this written out. So that will be your answer to that problem. Here's another example. This one has a negative in it, plus it has 2 variables. And so the thing to remember about a negative is when you get your answer for these, the signs should alternate. The first one will always be positive like it was up here, but then after that they should alternate. So the next one will be a negative, then a positive, then a negative, then a positive until you get to the end of the problem. So that's kind of a check for you to make sure your numbers or your answers are right. Alright, this says x to the 5th. So what I'm going to do is I'm going to go back to my triangle and I'm going to use that x to the 5th row. So that tells me these are going to be my numbers that are going to be out in front. Then I'm going to have 2x. It's going to start to the 5th power and go down. And then I have negative 3y. It's going to start to the 0 power and go up. Make sure you put the negative in with the 3y. Alright, so I have 1. I have 2x to the 5th, negative 3y to the 0. Plus, from my triangle, 5. 2x, decrease by 1, so 4. Negative 3y, increase by 1, so 1. Again, 4 plus 1 is 5, so you can check to make sure. Plus, back to the triangle, 10. 2x to the 3rd, negative 3y, goes up by 1, so that will be squared. Plus, another 10, 2x squared, negative 3y cubed, plus 5 times 2x to the 1, negative 3y to the 4th. Again, all of these add together every time to be 5. And then I'm going to squeeze the other one right down here. Plus 1, I ran out of room. 2x to the 0, negative 3y to the 5th. Alright, so that's how you write it out. Again, usually that is the longest part, but it's repetitive, so it's not that bad once you get the hang of it. Anything to the 0 power is 1. So, stick your numbers in your calculator. 2 to the 5th power is 32x to the 5th. Now, the signs should alternate, so as I stick this next number in my calculator, your answer should be a negative. So let's see. 5 times 2 to the 4th times, put your negatives in parentheses. So this is what it should look like. Make sure your negative number goes in a parentheses. You can raise it to the 1 power if you want. It's already understood to be to the 1, but I got negative 240, which is what we said we should have gotten. Go back, x to the 4th. Also here, I have a y to the 1. And so normally you don't write the 1, it's understood to be here. This one, remember, the y went away because it was to the 0 power. But here, I have x to the 4th, y to the 1. My next sign should be positive after I stick it in my calculator. So let's see. 10 times 2 to the 3rd times, I'm going to put my negative 3 in a parentheses, then I'm going to square it. So So make sure you always put your negative number in a parentheses. I did get a positive, so positive 720. Go back and do your letters, x to the third and y squared. Okay, I'm just going to keep going. 10 times 2 squared times, in parentheses, negative 3 to the third. Should be a negative, and it was. Negative 1080 x squared y cubed. Alright, we're down here to the one with the 5. So 5 times 2 times, in parentheses, negative 3 to the fourth. I should be at a positive answer if I did it right. And I got 810 x y to the fourth. X to the 1, y to the fourth. And then my last piece, anything to the 0 power is 1. So that went to 1. So in parentheses, negative 3 raised to the 5th power. This was a positive, so my answer should be a negative, and I got negative 243. And then don't forget your variables, y to the 5th. So now look at this. The first thing I see is my signs alternate. Plus, minus, plus, minus, plus, minus. Shouldn't have two pluses together or two negatives together. Then look at your variables. X to the 5th. It should get smaller. X4, X3, X2, 1x, no x's. And then the y's are completely the opposite. This one starts at 0. So 0 y's, 1 y, 2 y's, 3 y's, 4 y's, 5 y's. And that's your answer to that problem. So this would be your answer right here. Alright, so now it's time for you to practice some. If you go into your ebook, you can try these problems on the blank sheets that come after this. If you want to check your answers, you can check those. If you go into My Labs Plus, under chapter contents, there's a solution manual, and as you're working them, you can check your answers as you go along.